This is how you find true north using a gyroscope. This end of the room is north and this end south. The jar and the gyroscope, or the rotor motor, are part of a plumb bob which can swing and rotate. It's connected to the ceiling by a 2 meter 40 centimeter long string, and these wires are for the 3-phase motor. The 3-phase motor is being driven by a variable frequency driver. The motor is 400 cycles, 115 volts, 3-phase. It's come out of a British airliner. It's made by Smith's Aviation. It's about 1958. Okay, so the first thing we do is we get this arrangement as calm as we can. It's very sensitive. I've got these pieces of string just to fine cotton, really, just to give it a bit of more friction so it more quickly arrives at a state of calmness. But when I move around the room and talk, it is upsetting it a bit. But it's not so critical at this stage to get it so perfectly balanced. What we'll do is just mark where it swings to and from. It's about there. Okay, and then I lock the motor, the plumb bob arrangement, so it doesn't swing around when the motor starts. The motor takes quite a long time to spin up to speed. So we're halfway there on the motor. The rotor there weighs about 1.5 pounds. It's made of tungsten, so it's the same weight of gold. It's very heavy for its size. Okay, we're about there. It went a bit further than I was expecting. Okay, so that's it. So more or less all day long it's just going to keep swinging between those two positions. So you can see that although it was balanced here, there was a strong desire or force or something has made it rotate clockwise. Now the direction it's gone is not significant. If the arrangement was set up differently so that it was, at the moment, the orientation of the gyro is clockwise from an east-west direction. If it was set up anti-clockwise from an east-west direction, then it would go in the opposite direction. It's just the quickest route to get the axis of the gyro aligned as close as it can to the axis of the Earth. So when we take this off, the brake off, the matchboxes, we'll see that it more or less goes back to where it was before. Although it is going to go too far. So you can see the balance point is way over to the left there compared to what it did when the rotor was moving. Okay, so now it obviously wants to strongly go clockwise. I'm going to rotate it clockwise. Rotate the balance point clockwise. So I've got this arrangement on the ceiling here so that these three electrical wires don't interfere. They can't interfere from outside the suspension point, because that problem I had, that if the wires are pulling in any way on this suspended, on the plumb bob, it's really very, very difficult to adjust this without it really wanted to go back to where it was, but anyway, I changed the light fitting and I've got a very firm swivel light up arrangement up here. So I can turn this through 90 degrees and have some expectation that it will change 90 degrees at the bottom. I wish I had a bigger mirror on the bottom here. It's very fiddly. Okay. Good enough. Okay. Missed it. It's about there. Stickiness is wearing out. So it's 7.5 if they fall off. Okay. So the first time we did this, it was set up slightly clockwise of east-west. So if this is east, east-west, it was set up slightly like that. So if you're looking down at this arrangement, if east-west is here, it was set up slightly like that. And it strongly wanted to go clockwise. So I've now rotated it about 90 degrees. Okay, 2/3 of the way. That should do. So now it's wanting to rotate anti-clockwise. So I initially set it up slightly clockwise of east-west. It wanted to go clockwise. I rotated it about 90 degrees, although it is hard for me to make that adjustment very accurately. So I've gone past north, and now it wants to go back. It's wanting to go anti-clockwise now. But it's quite close because the balance point is in between the two extremes of the travel. And when it's, as best you can get it, the balance point is in the middle, exactly in the middle of the two limits of travel. And there's no preferred direction that it wants to go in. So this arrangement relies on two gyroscopic principles, I suppose. One is that the gyroscope shows this phenomenon of rigidity in space. It doesn't mean it's absolutely rigid, it just means that it has some inertia in a single point in space. It wants to stay in a certain position, and it requires significant forces to get it to change from that position. The other principle of gyroscope is precession, and because the gyroscope is tied to gravity and it is in a horizontal position, it can't really escape the horizontal position, although it can lean over slightly, it can rotate, but essentially it's bound to that horizontal position. But because it is tied by gravity, let me set up the next part of the experiment. So we've got to it went clockwise, so it wanted to go anti-clockwise, so we've got to rotate the suspension point slightly anti-clockwise. That's not enough. It's hardly moved at all. Okay, same thing. Fire up the engines. So you've got the two principles, if you like, the desire of the gyroscope to remain in the same position even when it is acted upon by slight forces. It's going to change. It will always change in any real gyro on Earth. So in an experiment like this, on the one hand you're trying to isolate the gyro from the Earth by having this long suspension system, but on the other hand it is tied to gravity, so it's not actually tied to the Earth, but there is a force that acts on the gyro if the gyro changes its position, or rather if the gyro stays where it is but the suspension point changes its position, then there's a force going to be applied to the gyro, and the second principle of the gyro is it will precess if the force is put on it. So this seems to be what is happening here, that the Earth is moving this way along with the suspension, and somehow the gyroscope is reacting to that. I've set this gyro up so the motor is going this way, but it doesn't make a huge amount of difference as to what happens here. It can go either way, but I've noticed that the reaction, the direction it goes is a little stronger, but that's about it. There's not a huge difference. Okay. Okay, so that's as far as it went. So what you notice is that when it's very far from true north it swings a long way, but as it comes closer the swing is less. So if we just rotate it now just a little more, we'll just get that little bit closer to true north. So it wanted to go anti-clockwise, so I rotated it up the top anti-clockwise to bring the balance point, because at the moment the balance point was there. If the balance point was here, then both of these would have swung, they'd be further over here. So the thing is trying to balance, it's trying to find a neutral position, but it can't. It can never find a neutral position, but when we find true north, it oscillates around the torsion-free position of the suspension system. Move the mirror slightly, and then we're going to have 3 positions recorded up there, or rather the laser. Okay. Let's do our balance point thing again. The professional devices have well, the older style ones anyway, it's all, everything's now totally automatic, but the older style devices, which you can sometimes see on eBay, they have a rectangular metal, strip of metal which is suspending the gyro, and you can view that to see whether it's twisted. So as the gyro rotates towards true north, you can free it from the suspension system from being twisted. So you arrive at the measurement much quicker, and the dampening, the swinging backwards and forwards, is computer eliminated, so you don't even notice that. All you've got to do is watch that wire and rotate the top part of the suspension system. And of course a surveyor knows to great accuracy approximate position of true north, but he doesn't know it within a few degrees. The string here is blocking the lasers, but I'm not going to change it. It'll only be blocked when it goes to that position. So I don't think I've explained exactly what's going on very well. I'll put it in the description. It's a bit difficult to... Gyros can be quite brain damaging, and it's easy to say things which are totally wrong because the whole thing's counterintuitive. But it's still quite an interesting experiment, this, in that you go to great trouble to somehow isolate the arrangement from the ceiling, and yet because of gravity and the fact that the ceiling is moving, so must the gyro. Okay, but if somebody's got a better explanation, I'm interested in hearing it, but at the moment we think the Earth rotates around an axis. Okay. Okay. So again, the oscillations got smaller and smaller. So it was, I don't know, it was pretty close to true north here, at that oscillation, and then here, and now we're still being pulled anti-clockwise. But I think that, without a screw, being able to rotate a screw to change the angle of the suspension system, there's no way that I can get it any better than that. We're just going to be going backwards and forwards, either side of true north. So that's how you find true north using a gyroscope. Thank you for watching.